Hello, I am Gal Hochberg, co-founder at Clear, and in this video I will demonstrate the proof of concept shown at MEF18 by a group of 7 service providers and 2 technology providers for on-demand inter-carrier data connection, quoting, ordering, and payment using blockchain technologies and recursive AI-enabled quoting. In today's hyper-connected world, the importance of high-bandwidth, low-latency global communication is rapidly increasing. With the incredible customer demand for video, and with new use cases such as virtual reality, self-driving cars, and remote medicine on the horizon, the ability to order high-quality connectivity between any 2 points on the globe is critical, even if it spans multiple carriers and technologies. The proof of concept will show, for the first time, a system for inquiring, quoting, ordering, settlement, and payment for an inter-carrier data on-demand connection working across 7 service providers using blockchain technology and an AI bot utilizing the MEF3.0 LSO Framework. The participating providers are PCCW Global, Tata Communications, Telecom Italia Sparkle, Singtel, CBCCom, Liquid Telecom, and Infonas. The technology providers are Cataworx, who build an AI bot with an intent-based interface for catalog digitization and recursive quoting, and Clear, who built the blockchain-based decentralized settlement network for ordering, reconciliation, and payment. The story begins with a fictional customer named Bankovia, who are having their annual company event and need to stream it live from their headquarters in 4K quality to the regional office in Japan. To stream the event, Bankovia need to order an on-demand circuit to the remote office. To do so, they will ask their service provider, the fictional Singtel, for a connection. However, Singtel does not have a termination in the Bankovia offices in Japan, and so will need to ask its providers to provide the connectivity. Here we see the customer view of the proof of concept. On the right is the Cataworx intent-based interface. The Bankovia employee is going to upload a quote request for a connection to the office in Japan. We can see the address in the CSV file. Now, we are seeing the interactions between carriers to provide the quote. As Singtel does not have a direct route to Japan, it will ask its providers, Infonas and Sparkle, for a connection. Infonas and Sparkle, in turn, do not have a termination to Japan, and so will ask their providers, Liquid and CBCCom. This will continue with Singtel and Tata until we reach PCCW Global, who can terminate. PCCW Global then responds with a quote of about $5.50 an hour. This response will then be passed up to Singtel, who will add their markup for transit, bringing the price to just over $6. This will continue until Singtel receives the final quote of $8.10 an hour. Note that even though this quote represents a connection across many different carriers, each carrier knows only about its closest neighbors. For example, Singtel does not know about Liquid or Singtel, but rather only about PCCW Global, its supplier, and CBCCom, its client. This is a critical feature of this PoC. Even though we are creating cross-carrier connections, the commercial details of suppliers or clients, or the structure of the supply chain itself, are not being exposed to the wider group, allowing carriers to maintain the privacy of their business information. Once the quote has been received by Singtel, the Bankovia employee can view the quote, even as a PDF file, as we will see now, and choose to accept it by entering a command into the bot interface. Once the order is placed, a chain of events begins to happen. The node at Singtel will make a decision to order from Sparkle, perhaps due to lower prices or lower congestion at the specific moment, and place an order on the shared blockchain between the 2 carriers. Sparkle will then automatically place a similar order with CBCCom on the shared ledger between the companies. CBCCom will with Singtel, and Singtel with PCCW Global. All these orders and prices are cryptographically signed, time-stamped, and stored in an immutable ledger, so that there is a full log of service providers' commitments to payment and service. Once PCCW Global accepts the final order, note how the circles turn green, a connection will be provisioned. In this PoC, the connections are simulated. However, in next stages and a production deployment, the carrier's orchestrators will work together, for example, by using the MEF3.0 interlude reference point to provision a connection between them. The connection will be provisioned in pieces until the circuit is complete, at which point Bankovia can successfully begin the company event and stream its video in real time. Let's skip forward. The event is complete, it was a great success, Bankovia is happy, and now it's time to pay for the service. The Bankovia employee can terminate the connection in the PoC interface. The termination command is passed using the blockchains between carriers all the way to PCCW Global. Note how when each connection is terminated, the supplier sends an invoice to the client, again using the blockchain network. Each pair of carriers now compares logs for the provisioned connection to see if there were SLA violations. In some of the connections, there may be discrepancies between the logs of each of the providers, and they will automatically reconcile any small difference. Once invoices are approved, payments are automatically made so that each provider keeps their fractional amount of the payment for service. Due to the carriers using a smart contract-enabled blockchain technology, the commercial contracts between them can be enforced such that if a carrier has ordered a service and agreed to a price, they will be required to pay that price, and foul play is discouraged. Additionally, the network is fully decentralized. There is no central server or repository, and each carrier only has information about itself and its relationship with neighbors. Privacy is fully maintained. And so, in the course of a few minutes, we have inquired for, quoted, ordered, used, terminated, and paid for a data-on-demand connection across multiple carriers. This process, that can take months today, can happen in seconds in the very near future. Moreover, this proof of concept has won the Silver Award at the MEF18 conference this year. We believe this is an incredibly exciting development and are now building a production-grade platform to bring this capability to market. If you have any questions about this video, please contact one of the participants in the proof of concept. Thank you.